Whales and dolphins depend on hearing to survive, but human technology is interfering in their world. The development and use of sonar by the U.S. Navy has had devastating effects on marine mammals. Sonar is the transmission of sound energy for the purpose of sensing the environment by interpreting features of received signals. The Navy uses these sophisticated ways of using sound to probe the marine environment. If you've ever seen a submarine, you probably came away with a basic understanding of how sonar works. Active sonar systems produce intense sound waves that sweep the ocean like a floodlight, revealing objects in their path. The Navy uses these different frequencies to detect different objects and images underwater. Some systems operate at more than 235 decibels, producing sound waves that can travel across tens to hundreds of miles across the ocean. Dolphins and whales rely on sound to survive. It is vital to their survival for hunting, navigating, and communicating. Dolphins use echolocation. Echolocation is the ability to locate objects by bouncing sound waves off of them, and then measuring the time taken for an echo to return, and calculating the direction the echo came from. Whales generally produce a series of sounds for communication. Almost all marine life depend on some amount of sound for survival. When a sound in the ocean 1,000 times more powerful than what they are used to is used by the Navy, the results can be devastating and even deadly. One of the most important senses for dolphins, whales, and other marine life is hearing, and losing it is likely to cause them to become disorientated and alarmed. Mass strandings of dolphins and whales could be caused because the animals are rendered temporarily deaf by military sonar. Tests on a captive dolphin have demonstrated that hearing can be lost for up to 40 minutes on exposure to sonar. Several strandings of dolphins and whales in the past decade have been found to be caused by sonar, according to the Hawaii Institute of Marine Biology. And although some strandings are still thought to be naturally occurring events, tests have proved fears that exercises by naval vessels equipped with sonar are definitely responsible for some of them. The study also suggested, however, that dolphins and whales would usually be able to swim away fast enough and far enough to escape any ill effects from the sonar. To induce deafness in the Atlantic bottlenose dolphin, the sonar device would have to be loud, close, and would need to last for at least 2 minutes. This could give the animals plenty of time to escape, but in some circumstances, noises can be caught in underwater traps. Experts from the University of Hawaii have determined that sound can become trapped if a layer of warm water lies over cold water. When sound created in the warm zone reaches the cold water, it can bounce back instead of traveling through it. This would have the effect of trapping the sound in the warm layer, where it would bounce around like a ping pong ball, giving whales and dolphins little chance of escaping it. Similar effects could be experienced in parts of the sea with mountains and ravines, where the sound could bounce back and forth. This could explain why 3 of the best-known strandings that have been linked to military sonar in the Bahamas, the Canaries, and Hawaii, because all 3 regions have a mountainous underwater topography. In the Bahamas in March of 2000, 16 beaked whales and Blainville's beaked whales and a spotted dolphin beached during a U.S. Navy exercise in which sonar was used intensively for 16 hours. Sound traps might also go some way to explaining why there are only a few mass strandings compared with the frequency with which sonar is used by Navy vessels. The big question is what caused them to strand. What we are looking at these animals whose primarily sense is hearing like ours is seeing. Their ears are the most sensitive organ they have. What we found was if you play sound, you can cause temporary hearing loss. The sounds have to be surprisingly loud, and they have to be repeated over an extended period of time, 2 to 3 minutes. In that time, you would expect them to swim away as fast as possible. They have to be within 40 meters of a ship, but when you have certain oceanographic conditions, it is hard for the animals to get out of the way. Observations by researchers while carrying out the test which are reported in the journal Biology letters, showed that even though the dolphin involved was well accustomed to man-made noises and disturbances, it suffered behavioral changes, which could cause further confusion. The use of sonar can drown out the noises marine mammals make and rely on. By the Navy's own estimates, these sonic waves can retain an intensity of 140 decibels up to 300 miles away, which is 100 times more intense than the level known to alter behavior in marine mammals. Many, but not all, strandings have been caused by the use of sonar. In 2000, the government's investigations established that sonar was responsible for the strandings of at least 4 different species of whales in the Bahamas. Similar mass strandings have occurred all over the world. Although strandings are the most visible of the problems caused by sonar, they are not the only ones. Scientists believe that the Navy's mid-level frequency sonar blasts may drive certain whales and dolphins to change their dive patterns that their bodies cannot handle, causing fatal or debilitating injuries. Deadly impacts of sonar have been determined on beached whales and dolphins, which are found with the same signs of physical trauma, including bleeding in the brain, ears, and other tissues, and large bubbles in their organs. These injuries similarly known to scuba divers who surface too quickly. There are many other problems that sonar can affect marine life. It has proved to disrupt feeding and other vital behaviors of marine life. Scientists worry about the cumulative effect sonar will continue to have. What can be done? Some peacetime use of military sonar has been regulated by the Marine Mammal Protection Act, and other statutes have been put into place due to the concern that the use of active sonar has on marine life. By avoiding the use of sonar in vital whale and dolphin habitats and important whale migration paths, we can help to prevent and protect our marine life. Common sense and continued regulation of sonar testing can prove to help lessen the negative impact on marine life.